Hi, welcome to Dumble PH. So our topic for today in this video will be about the history of the Earth. Now let's talk about the age of the Earth. The Earth has a very long history, about 4.6 billion of years of history. So we are talking here about Earth. The age of the Earth is based from the radioactive isotopic dating of meteorites. And the oldest dated rock from Earth is only 3.8 billion years old. Now, for the rock and fossils, the history of the Earth is recorded in rocks, but the rock record is inherently incomplete. Some of the events do not leave a record or are not preserved. Some of the rock record may have also been lost through the recycling of rocks. So, recycling of rocks, so you can recall the rock cycle. Preserved in rocks are the remains and traces of plants and animals that have lived and died throughout Earth's history, or they are called fossils. The fossil record provides scientists with one of the most compelling evidence for Charles Darwin's theory of evolution. So this theory is about the increasing complexity of life through time. Okay. Now let's talk about the geologic time scale. This scale is the timeline of the history of the Earth, and it is based from the rock record. Geologic time is subdivided into hierarchical intervals, the largest being aeon, followed by era, period, and epoch, respectively. Subdivision of geologic time is based from significant events in the Earth's history as interpreted from the rock record. The mass extinction event, which led to the extinction of the dinosaurs, occurred around 66.4 million years ago, marks the boundary between the Mesozoic era, or the age of the reptiles, and the Cenozoic era, or the age of mammals. This mass extinction event may have been pivotal in the rise in dominance of the mammals during the Cenozoic era. Now, as you can see in this pie chart showing relative proportion of the major subdivision of geologic time, one of the first to recognize the correspondence between the rocks and time is Nicholas Steno. Okay, take note for Nicholas Steno. Steno's principles, superposition, original horizontality, and lateral continuity became the foundation of stratigraphy, the study of layered rocks. Again, stratigraphy, the study of layered rocks. Since the geologic timescale is based on the rock record, the first order of business is to establish the correct succession of rocks. Initially, this was done using relative dating techniques. One of the earliest attempts to subdivide the rock record into units of time was made by Abraham Gottlob Werner. Okay, again, it was Abraham Gottlob Werner. He is a German geologist. So Werner divided the rock record into the following rock time units from oldest to youngest: primary, secondary, tertiary, and quaternary. Werner used the principle of superposition extensively to establish temporal relationship among the rock units. Fossils are also useful in determining relative ages of rocks. William Strata Smith, while working in a coal mine, observed that each layer or strata of sedimentary rock contained a distinct assemblage of fossils which can be used to establish equivalence or correlation between the rock units separated by long distances. Moreover, he observed that these fossils succeed each other vertically in a definite order. Whereas William Smith used fossils primarily to identify rock layers. Charles Lyell, British lawyer and geologist, recognized the utility of fossils in subdividing geologic time on the basis of fossils. He was able to subdivide the tertiary by examining the proportion of living versus extinct fossils in the rocks. The underlying reason for this definite and orderly succession of fossils in the rock record is organic evolution. Take note for that, organic evolution. Now for the evolution of Earth's history, fossils are an essential part of subdividing the geologic time because fossils are their evidences on how they divided the geologic time scale. Now, biostratigraphy, it is a subdiscipline of Stratigraphy, which deals with the use of fossils in correlation and establishing the relative ages of rocks. Index fossils are marker fossils used to define periods of geologic time. Ideally, index fossils are distinctive and can be easily defined and distinguished from other fossils. Widespread distribution is not confined to a few localities and have limited geologic time range. Ultimately, the geologic time scale was assigned numerical dates, absolute dating. Okay, it's because of absolute dating, and this process is through the radiometric dating of rocks. So we have here um, the eras, as we can see here in the geologic time scale. First, we are going to know what does GA means. That is giga-annum. MA means mega-annum. Okay, if we say giga-annum, it is in billion years, while mega-annum, it is in million years. Now let's start from the Precambrian or Cryptozoic era. So from 4.6 billion years to 540 million years. It represents 80% of Earth's history. So ito ang the longest period in the Earth's history. So this era is named or considered as the Aeon of hidden life. So fossil record obscure. There is very little record of life during the Precambrian because there is not much life in this period, with only simple life forms existed and may not have preservable hard parts. Okay. Next, we have the Hadean Aeon. It is from 4.56 billion to 3.8 billion years. From the name came from the Hades, the Greek god of the underworld. So this is a chaotic time. There are lots of meteorite bombardments. The atmosphere reducing, it has the atmosphere reducing methane, ammonia, and carbon dioxide. Start of the hydrological cycle and the formation of the world oceans, and then life emerged in this hostile environment. Next, we have the Archean Aeon from 3.8 billion years to 2.5 billion years. It is anaerobic. In this aeon, it lacks oxygen. There is no ozone. The photosynthetic prokaryotes or blue-green algae emerged and started releasing oxygen to the atmosphere. Life forms still limited to single-celled organisms without a nucleus, or to what we so-called prokaryotes, until 2.7 billion years when eukaryotes emerged. So there we can say that the prokaryotes first emerged, then the eukaryotes. Next, we have the Proterozoic Aeon. It is from 2.5 billion years to 540 million years. In this aeon, the oxygen level reaches approximately 3% of the atmosphere. It is when the rise of multicellular organisms, or the eukaryotes, represented by the Vendean fauna. Okay, so formation, it is where the formation of the protective ozone layer happened. Next, we have the Phanerozoic Aeon from 540 million years until present. We can also say that Phanerozoic Aeon is until present. So it is the Aeon of visible life. Of course, we can see life everywhere. The diversification of life, many life forms represented in the fossil record. Okay, so the life forms became diverse in different versions. Life forms with preservable hard parts in the Paleozoic era. Then, life forms with preservable hard parts. That is for Phanerozoic era. Then for the Paleozoic era, it is the age of the ancient life. Okay, we say Paleozoic era, it is from 540 to 245 billion years. The rapid diversification of life, as represented by the Cambrian fauna or the Cambrian explosion. There's dominance of marine invertebrates. Then plants colonized land by 480 million years. Animals colonized land by 450 million years or mega-annum. Oxygen level in the atmosphere approaches present-day concentration and there is massive extinction at the end, or it is the end of Permian extinction. Next, we have the Mesozoic era after the Paleozoic. So it is also called as the age of reptiles, the dominance of reptiles and dinosaurs. So Pangaea starts to break apart by 200 mega-annum. Pangaea is the largest continent. Okay. Early mammals, 200 early mammals exist. Then first birds in the 150 mega-annum. Then first flowering plants in 130 mega-annum. Then the mass extinction at the end of the Cretaceous, we have in the 65 mega-annum. And lastly, we have the Cenozoic era. It is the age of mammals. It is from 65 million years or mega-annum to present. There is radiation of modern birds. We have the early primates at 60 mega-annum. Then continents near present-day positions, we have 40 mega. In the 40 mega-annum, this continents near present-day positions, we have the 7 continents, formation of the 7 continents. Then we have the first hominids before humans. Then the modern humans exist. Then the global ice ages begin in the 2 mega-annum. So look at this. As you can see in the picture, it is well arranged and so that you can understand properly the geologic time scale and take note for the relevant and important events that happen in each time scale, like in the aeon part, in the era part, in the period part. Okay, so that's it.